Container security. What is containerization? In computing terms, containerization is the process of packaging an application and the necessary resources, such as libraries and packages, required into one package named a container. The process of packaging applications together makes applications considerably portable and hassle-free to run. Modern applications are often complex and usually depend on frameworks and libraries being installed on a device before the application can run. These dependencies can be difficult to install depending on the environment the application is running. Some operating systems might not even support them. Create difficulty for developers to diagnose and replicate faults, as it could be a problem with the application's environment, not the application itself. Can often conflict with each other. For example, having multiple versions of Python to run different applications is a headache for the user, and an application may work with one version of Python and not another. In the picture above, we can see how three applications and their environments, such as dependencies, are packaged together and do not directly interact with the physical computer, but rather the containerization engine. Introducing Docker. Docker is a relatively hassle-free, extensive and open-source containerization platform. The Docker ecosystem allows applications to be deployed, managed and shared with ease. Working on Linux, Windows and macOS, Docker is a smart choice for running applications. Applications can be published as images and shared with others. All that is required is pulling the image and running it with Docker. Docker engine. Docker employs the same technology used in containerization to isolate applications into containers called the Docker engine. The Docker engine is essentially an API that runs on the host operating system, which communicates between the operating system and containers to access the system's hardware, such as CPU, RAM, networking and disk. Because of this, the Docker engine is extensive and allows you to do things like connect containers together, for example, a container running a web application and another container running a database. Export and import applications, images. Transfer files between the operating system and container. Docker uses the programming syntax YAML to allow developers to instruct how a container should be built and what is run. This is a significant reason why Docker is so portable and easy to debug. Share the instructions, and it will build and run the same on any device that supports the Docker engine. The Docker engine allows containers to be orchestrated, meaning that multiple containers can be built as part of a group, allowing containers to communicate with each other. Fictional story of Docker. One Moby, the whale, as Docker's logo. The whale in Docker's logo is a direct reference to the whale Moby Dick from Melville's novel. This connection symbolizes Docker's capability to handle vast and complex environments, much like the mighty whale in the ocean. To Captain Ahab. Captain Ahab is obsessed with hunting down the great white whale, Moby Dick. This relentless pursuit is emblematic of Docker's mission to conquer the complexities and challenges of software containerization and distributed systems. 3. Conceptual inspiration. The novel Moby Dick represents exploration and the pursuit of a formidable goal, mirroring Docker's journey to simplify and revolutionize application deployment and management. Docker's developers and community often face complex challenges, akin to Captain Ahab's pursuit, but with the aim of taming these challenges rather than being consumed by them. 4. Whale imagery. The whale as a metaphor extends to the Docker ecosystem, where the whale signifies the power and vastness of Docker's platform to carry and run numerous applications, represented by the containers, across diverse environments, much like the ocean carries a multitude of life forms. The history of Docker. Originally created by Solomon Hykes in 2013, Docker is open source and has become a well-renowned name within containerization. Docker started as an internal project for .cloud, a PaaS provider, where it was then showcased in PyCon in 2013 and then quickly made open source. While containerization's original concepts started in 1979 with Unix v7, Docker has made containerization a popular technology since its release in 2013. Docker's popularity is due to making the benefits of containerization accessible and modern. As of April 2022, it is fair to say that Docker is extremely popular. 13 million developers are using Docker. There are 7 million applications made and ready to use with Docker. 13 billion applications are downloaded monthly. And this is just from the official repository. Here is the benefits and features of Docker. These all are the basic Docker commands. Dockerfile. Dockerfiles play an essential role in Docker. Dockerfiles is a formatted text file which essentially serves as an instruction manual for what containers should do and ultimately assembles a Docker image. You use Dockerfiles to contain the commands the container should execute when it is built. To get started with Dockerfiles, we need to know some basic syntax and instructions. Dockerfiles are formatted in the following way. Docker Compose. What Docker Compose is and why it's worth understanding. So far, we've only interacted with containers individually. Docker Compose, in summary, allows multiple containers, or applications, to interact with each other when needed while running in isolation from one another. Before we demonstrate Docker Compose, let's cover the fundamentals of using Docker Compose. We need Docker Compose installed. It does not come with Docker by default. Installing it is out of scope for this room, as it changes depending on your operating system and other factors. You can check out the installation documentation. We need a valid dockercompose.yml file. We will come on to this shortly. A fundamental understanding of using Docker Compose to build and manage containers. I have put some of the essential Docker Compose commands into the table below. Format of dockercompose.yml files. One file to rule them all. The formatting of a dockercompose.yml file is different to that of a Docker file. It is important to note that YAML requires indentation. A good practice is two spaces which must be consistent. First, I'll show some of the new instructions that you will need to learn to be able to write a dockercompose.yml file before we go into creating a dockercompose.yml file. Here is the new instructions. Docker socket. This task will explain how Docker interacts between the operating system and the container. When you install Docker, there are two programs that get installed. One, the Docker client. Two, the Docker server. Docker works in a client-server model. Specifically, these two programs communicate with each other to form the Docker that we know and love. Docker achieves this communication using something called a socket. Sockets are an essential feature of the operating system that allows data to be communicated. There could be two sockets. One, a socket for storing a message that you are sending. Two, a socket for storing a message that someone is sending you. The program will interact with these two sockets to store or retrieve the data within them. A socket can either be a network connection or what is represented as a file. What's important to know about sockets is that they allow for inter-process communication. This simply means that processes on an operating system can communicate with each other. In the context of Docker, the Docker server is effectively just an API. The Docker server uses this API to listen for requests, whereas the Docker client uses the API to send requests. For example, let's take this command, docker run hello world. The Docker client will request the Docker server to run a container using the image hello world. Now, whilst this explanation is fairly basic, it is the essential premise of how Docker works. Let's look at the following diagram to show this process in action. Some of the Docker terms. 1. Docker Hub. Docker Hub, link resides outside ibm.com, is the public repository of Docker images that calls itself the world's largest library and community for container images. It holds over 100,000 container images. They can also download predefined base images from the Docker file system to use as a starting point for any containerization project. Users of Docker Hub can create a repository, repo, which can hold many images. The repository can be public or private and can be linked to GitHub or Bitbucket accounts. 2. Docker Desktop. Docker Desktop is an easy-to-install application that simplifies working with Docker on your local machine, especially if you are using Mac or Windows. It includes several essential tools. Docker Engine, the core component that runs containers. Docker CLI Client, a command-line interface for managing containers. Docker Compose, helps define and manage multi-container applications. Docker Content Trust, ensures the integrity of images. Kubernetes, a powerful container orchestration platform. Credential Helper, manages authentication tokens for Docker Hub and other registries. 3. Docker Registry. A Docker registry is a scalable open-source storage and distribution system for Docker images. The registry enables you to track image versions in repositories, using tagging for identification. This tracking and identification is accomplished using Git, a version control tool. A registry stores Docker images. It is a popular public registry where you can find and share container images. Registries can also be privately managed. 4. Docker Daemon. Docker Daemon is a service that creates and manages Docker images, using the commands from the client. Essentially, the Docker Daemon serves as the control center of your Docker implementation. The server on which Docker Daemon runs is called the Docker host. It listens for Docker API requests and manages Docker objects like networks, volumes, containers, and images. It communicates with other daemons when managing Docker services. 5. Docker Images. Images are read-only templates that include everything needed to run an application: code, runtime, system tools, libraries, and settings. A Docker image is a file used to execute code in a Docker container. A Docker image is a file used to execute code in a Docker container. Docker images also act as the starting point when using Docker. An image is comparable to a snapshot in virtual machine, VM, environments. It have multiple layers, each originating from the previous layer but different. It is immutable. They can't be changed, can be duplicated, shared or deleted. See in next video.